Hi everybody, I'm Jim White, and this video is about safety. Safety in producing art like is behind me here. This is called Lichtenberg wood burning or fractal wood burning, and it produces figures similar to lightning, which then can be enhanced to produce items like this. Here, watercolor has been added to make these appear like landscapes. And in this case, the deep grooves that occur while making the figures has been filled with blue epoxy. But the equipment to do this kind of stuff involves high voltage, and I see a lot of videos on YouTube of people doing extremely dangerous things to produce these figures. So the majority of this video is about the safety considerations to think about while doing this. There's rumors that people have been killed, electrocuted, while attempting to do this. So this must be taken seriously. So let's go look into the safety issues. Most people doing the fractal wood burning use a transformer from a microwave oven. And the dangers actually first start when retrieving parts from a microwave. The first hazard is this capacitor right here. They're mounted in various different ways. This is just the bracket to hold it. Some are clamped at the bottom. Some have straps around the middle. But the danger is this capacitor could be charged. And it's highly unlikely, but you don't get a second chance. So you should take an insulated screwdriver and short between the terminals as soon as you find this thing in the microwave. Now, I've included some videos under the Show More tab about how to remove parts from a microwave. So another hazard you'll run into is from the magnetron. While getting the transformer out, you want to be sure not to damage. See that pink area there? Sometimes it's white. That may be beryllium oxide, which is hazardous to your health if you breathe dust from it. So you don't want to crack or scrape that part. There's also a part on the other end which you cannot see right now that is the same way. Now, while we're looking in here, you see two magnets. That's the black round things. They're actually shaped like donuts. They have a hole in the middle. And some people want to retrieve those. So watch the videos that I've listed on how to get those magnets out without damaging that beryllium, or what may possibly be beryllium. So with those dangers in mind, now let's look at the transformer itself. These wires here are from a winding that's between the other two windings, and that's the filament supply for the magnetron. And those wires produce about 3 volts, and you can just cut them off and insulate the ends, because you typically don't use those. The primary winding is the fat heavy wire, and you see here the connections are made to it with quick disconnects, which you can just pull off and hook up your input power to. Now, the one I'm touching with my thumb is the high voltage winding, and you can see the end of that winding is connected to the frame of the transformer. So that means that all the metal of this transformer is at high voltage potential when you're in operation. So that's a hazard you have to be aware of. Never touch it. And here's the other end of the high voltage winding, this tab here. Now here's another transformer. Everything's very similar. It has a winding for the filament of the, this is just some additional insulation. So this is the filament winding, and it produces about 3 volts. And if I turn this thing over, there it is. So here you can see where the high voltage winding is connected to the frame of the transformer. And here's the input to the primary winding. Again, it's quick disconnect connectors that you can remove and reuse. Now in this case, the high voltage output is a wire. So, you know, there's minor differences between all these transformers depending on the brand of the microwave. So that's the primary winding. This is the secondary winding. This one happens to be sitting on a bracket, and the other one is welded to a bracket of a different shape. So to make connection to the side of the high voltage that's connected to the transformer body, you can use the screws, holes that were used to mount the transformer originally. Now sometimes the transformers are just held in with clips, and actually these get dipped in varnish. So to make contact with the frame, you have to scratch the varnish away, and you can use a screw and nuts to make a connection to the frame. And again, you never want to touch either this high voltage output or the body or the wire connected to the frame of the transformer. And I'll warn you a little more as we go on. But this is just the starting point, and I hope you can see the dangers that might be involved already. Oh, I just remembered another potential hazard from the capacitor. This type of capacitor is filled with oil, and as are capacitors and transformers that you see hanging on utility poles. And this oil can be a very nasty type. They used to use oil that was carcinogenic. And you can see this little dot of solder here. That's plugging the hole where the oil was injected into the capacitor. So never, ever open one of these up. Just think there's deadly stuff inside, and you don't want to mess with it. This is my setup for when I do the fractal wood burning. My transformer came from a fairly small microwave, so it's smaller than the other ones that I showed you. The white wires there are the filament winding, and they're on top of the high voltage winding. So I have the transformer mounted to a piece of PVC. You see, it's not mounted to the wood itself. and then totally covered with clear PVC sheet. And this is 1/16 inch thick PVC. And what I like about it is you can shear it in a normal metal shear, and you can bend it in a normal metal bending brake. And then it's held together with nylon screws. Now I get the PVC sheet in 1 foot by 2 foot pieces at McMaster.com. Also the nylon hardware. Now what's in the little box here is a sonic indicator that howls whenever there's voltage applied. I like to run from a variac so I can control the voltage, and I want to make sure I don't leave it half on or something by mistake. So my unit produces a sound down to very, very low voltages. And what's in that box is a sonic alert unit, and I got this one at Mauser.com. And it's really loud even at 3 volts. So originally I had a slot in the side of the box here to let the sound out. Originally I thought I could put a piece of tape over the hole, but that stops the oscillator when you do that. So even the slot was left too much sound out, so I put a piece of tape over that. But here's the schematic of what's in there. And the 5-volt Zener limits the applied voltage, or the thing would be super loud. So the unit's rated 3 to 28 volts, and it does start at 3 volts and is very loud. Now the probes that I use are made from acrylic rod, and the feet here are made from acrylic sheet. Now acrylic's very brittle. You can't shear that or bend it without it shattering. So normally I set these on the wood that I want to burn, and then bring the variac up slowly and then control the voltage so that I don't burn big deep grooves in the wood. And these probes hook up to the terminal block here when I'm ready to go burn some wood. The wire that I used here is rated at 20,000 volts, and it's 20 gauge wire, and I also get that from McMaster.com. And I think you can see that insulation's pretty thick. This wire is very flexible because it's made up of many strands of a very fine wire. So I guess that's the next thing we need to do. You might be tempted to want to ground that transformer. Don't do that, because then there's a danger of having a path to ground from the other probe. The way it is now, neither probe has a path to ground. And I also wanted to point out this piece of wood is up on rubber feet, just in case we spill water while painting the soda solution on the wood. I want to make sure that wood does not get wet. So I guess the next thing is to burn some wood. Here's the setup that I use. I have the high voltage transformer plugged into a variac, and that way I can vary the voltage and therefore the depth of the burn somewhat. Now generally you get a burn going from each end towards the middle, and you usually want to stop it before they meet or you get a big bunch of current. And I like to do burns that just go in one direction so that they look like trees, and then I can use watercolors to color along the grain of the wood to make sky and features that look like earth or ground. And I'll show you how to make it go in one direction only. Here's a paper towel with a bare copper wire running through it, and then the ends are folded over to hold the towel together. And what I'm going to do is saturate that in a stronger baking soda solution, perhaps 2 tablespoons per cup. And let's do that. Here I'm using a plastic eyedropper that I get from McMaster.com. They're about 12 cents in packs of 10, I believe it is. So we want the paper towel saturated really good. And then we're going to use our regular solution to paint the area where we want the tree to grow. And then we want this top area really saturated so that it's highly conductive. And because it's highly conductive, we won't get a burn in that area. Okay, there we see how the burn goes in only one direction. And after we wash the board off, there'll be much finer detail there as we get the charred carbon off of the board. This is a piece of poplar. Okay, I hope that you noticed that I didn't touch anything when the voltage was turned on. You need to stay away totally from that high voltage. And don't attempt this if you don't feel confident in the field of electricity. At these voltages, you just don't get a second chance. So please be careful.